All right, so let's start this new chapter. In your book, they discuss other chapters before this talk about electricity, but I feel that because electricity is such an important topic, and since your schools are just starting, I would like that we do this one before there's a high momentum of things that you have to cope with. So electricity is about, and the one I'm talking about over here is about moving charges. So electricity is basically the study of charges, and there are two ways of looking at it. One is when the charge is not moving, which we call static electricity, and the charge just stays there. And what happens when it does that? Because opposite charges attract, so many wonderful things happen due to static charge. Also, some annoying things. And then there's the current electricity, which is like one of the major forces in our modern civilization. And current electricity is what we're going to study first. And then we'll talk about static electricity. So a few rules that you need to know. First of all, you need to know that there's a thing called charge. And charge is something that is inherent to matter. So matter has charge, and we don't really understand where it comes from. Like, why does charge exist? We don't really know the answer to that question. But what we do know is that charge is there. Charge is conserved, which means that overall charge, the amount in nature is constant. And whatever amount we have since the beginning of time, it's going to be, that's what we have. Charge can neither be created nor destroyed. And that's it. Charge is there. Second thing that we know about charge is that charge is of two kinds. There's the positive charge and there's the negative charge. They don't really have anything that makes it positive or anything that makes it negative, except that that is how people name them. So they named one of them positive and one of them negative. Okay. And then they said that, all right, the charge that is on electron is negative and charge that is on proton is positive. And that's it. So that's something that we get from convention. There is no reason or there's nothing in there that will tell us that nahi, positive बनने के लिए कुछ खास होना चाहिए. Sure, there are, we do have a standard model that tells us that positive charge के लिए इतने up quarks होने चाहिए और इतने down quarks होने चाहिए and all that. Sure, the model is there. But why does that work like that? We don't really know. ठीक है? So charge positive होता है, charge negative होता है. Third thing, charge is quantized. What that means is that there is a packet of charge जिससे छोटा packet आप नहीं बना सकते. ठीक है? So for example, if you talk about negative charges, then the smallest packet of a negative charge that you can get isolated, like individual charge move कर रहा है या पड़ा हुआ है, that can be -1 of the electron. Okay? So एक electron is the smallest packet of charge that you can get. या जितना उस पे charge है उससे छोटा charge आप individually नहीं रख सकते आप. Sure, mathematically it makes sense. अगर एक electron के ऊपर charge है, the charge is 1.6 into 10 power minus 19 coulomb. You don't need to remember the value, but you do need to know that the unit is C, which is coulomb. So it's a French word, actually a French name, coulomb. The B is silent, okay? So 1.6 in 10 power minus 19 coulomb, which we call 1E, that is the smallest charge that you can get. It is quantized. इससे छोटा नहीं मिलेगा आपको. In fact, इससे बड़ा भी आपको वही मिलेगा, which is a multiple of it. ठीक है? आप just like if you buy Kokomo, then you can get one packet, or you can get two packets, or you can get a bigger packet which has probably 5 packets in it. But that's what you get. You can't get half a packet from the shop, right? It will be a really weird shop if they start selling that. So just like that, charge is quantized. It always comes in fixed packets. And sure, you can get a billion or a million Kokomos, but वो सारे के सारे उतने packets ही होंगे. Just like that, you can get as much charge as you want, but as long as it is made of these small packets, and each of these packets has this much. And it doesn't matter whether it is positive or a negative, because positive and negative both have equal number of charge on them. Okay, so positive के ऊपर ये positive 1.6 in 10 पर minus 19 है, जिसको हम positive 1e बोल सकते हैं, और negative के ऊपर negative इतना है, and the charges are the same, which is why matter is usually neutral, because the number of protons and electrons in any atom, they are equal. So they bring equal amount of charge, but it's opposite in terms of sign, so it cancels out. Okay, so three things that we know about charge. Number one, it is conserved. It can neither be created nor destroyed. Second, it comes in positive and negative form. And third, it comes in fixed packets, and you can only get it in those. You cannot get half a packet or 1.5 packet or 1.35 or something. You can't. You will always get it a multiple of these. ठीक हो गया? Now charge can flow, and when it does that, it can carry energy with it, because you know when things move, they have kinetic energy in them. But if you're able to direct charge, if you're able to make it go from one point to another in a direction, then we call that current electricity. Current itself कुछ भी हो सकता है. Current can be a current, water current होती है, air current हो सकती है, ठीक है, which is moving. Current is anything that is flowing, okay? But current electricity means flowing of these charges, in fact, charged particles that carry energy with them. So how does that work? First of all, we have to understand that not every charge flows. For example, if you talk about metals, then they have positive charges in them and they have negative charges in them. Positive charges come from cations and negative charges come from free electrons. Now those electrons, they are free, they can move around, but cations cannot. So in metals, only the free electrons move. But if you have liquids that conduct electricity, we call them electrolytes, then those liquids might have positive and negative ions, and they will both have charges on them and they will both move. Similarly, you can have negative electrons and positive ions if you melt a metal, or in the case of mercury. So they'll be both be moving. So that makes them, so if they're both moving, they're both charged particles, it's fine. As long as you have a charged particle that's moving in a direction, that can be called a current electricity. Current itself makes no sense. हाँ, आप electric current कह सकते हो उसको, ठीक है? Itself current का context पे depend करता है. Water current, air current, move कर रहा है ना? The unit of current is ampere, again named after a scientist. A for ampere, and that is how we measure कि कितना charge move कर रहा है. So the idea of what current is basically how much charge is moving per unit time. That's the idea of current. So current, because again the name comes from French word intensity. Okay, so that is why current को हम I बोल देते हैं. Intensity की वजह से French में से intensity बोलते हैं, तो उसको हम I बोल देते हैं. And charge has this term Q associated with it. I never really thought about it. कि Q क्यों होता है? Sure, कोई reason होगी. And then we have T there, and T is for time. So I is Q over T. In fact, this is a definition of current. That is why we can write a triangle there. And this triangle shows that what current is and what the definition of current is. So अगर कभी आपसे definition मांग लेता है, you can just explain this definition, this formula, and you will have answered the question. So any formula that defines stuff, you can simply state that formula. So what is current? Current is rate of flow of charge per unit time. That's it. That's what current is. And that's basically the formula. The unit is ampere. How do you get that? What is an ampere equal to? So on this side, you have ampere, and on this side, you have coulomb over second. So if I say my charge is 1 ampere, what does that mean? It means that I have 1 coulomb passing per second, or I could have 2 coulombs passing per 2 seconds, which is the same as 1 over 1. Okay. So if I have 1 coulomb passing in 1 second, that means it is 1 ampere. Similarly, if I say my charge is 5 ampere, so that would mean that 5 ampere is 5 coulomb per 1 second. So for example, if you have, so you get electricity from some electric power supply company. So for example, in Lahore, we get it from Lesco. So they are going to give us every charge that they deliver to our homes. They say it will have equal amount of energy in it. And I'll briefly talk about what that is. लेकिन उनकी गारंटी ये होती है कि हम आपको एक जितने एनर्जी वाले चार्जेस डिलीवर करते हैं. Okay, but let's suppose I want to, on one hand, I want to charge my phone, and on the other hand, I want to turn on the AC. Now, AC is a big device. AC needs lots of energy compared to my phone, which doesn't need that much energy when it's charging. In fact, my phone cannot handle as much charge at the same time as the AC can. Okay, so how does the AC get more energy and phone get less energy, even if they're both connected to similar wiring? So the answer is that the AC is going to ask for more charges per unit time. And remember, every charge has same amount of energy. So AC will ask for more charges, but my phone will ask for very little charge. Okay, so I can easily say that, let's suppose my phone is working on 0.5 ampere and my AC is working on 5 ampere. What that means is that every 1 second, my AC gets a charge of 5 coulomb every second. And since every charge has the same energy, it gets a lot of energy. But on the other hand, I have 0.5 ampere, which basically means 1 coulomb charge flows in 2 seconds. So every 2 seconds, there's 1 coulomb coming in. So that's very little for the phone. Okay. So that is how we are able to run different things who have totally different requirements for energy using the same wiring, because we just change how much current flows or how much number or what number of charges are able to come and go. The second important thing then when we talk about it is that, remember, the reason we are making these charges go is because we want to deliver energy. So that is called voltage. And voltage is basically the energy. So that is energy that is given to each charge. So again, that's the definition. So V equals E over Q. So that is energy or E or work done per charge. Okay. What does it mean, work done? So basically, if you have a charge moving through a wire, so you know that that wire has a metallic lattice in it, most likely. And obviously, those are going to resist how much that charge flows in it. It's not going to allow that electron to just move around. It's going to repel those electrons. Free electrons होंगे, वो उस electron को जाने नहीं देंगे, वो उसको repel करेंगे. उसका रास्ता टेढ़ा मेढ़ा सा होगा. कभी वो आगे जा रहा है, उसको repel करें, कभी इधर जा रहा है, repel करें. That is how the wires get even hot, क्योंकि वो energy उसकी बहुत ज़्यादा लग जाती है move करने में. So moving that charge inside the wire or even into electrical appliances requires some energy. And the energy that you take per charge, that is voltage. Now, voltage can be of two kinds. One we call EMF. And the second we call potential difference. And the difference in these two is simply whether you're supplying energy or whether you're taking energy. So there are two ways you can deal with this. You can give energy to a charge and ask it to take that away. Okay? If you're doing that, then you're increasing the energy that every charge has. That is called electromotive force. Now the name is actually, it's a misnomer. It's not a force, okay? But people who first found it, they thought that, oh, basically a battery just forces the charge to move. So they said कि उसको electron को motivate कर रही है ये force. So that's how it moves. But actually that's just fiction. It doesn't work like that. Now we know that. But उस time नहीं पता था. So we say that if you take a battery or if you take this power socket or all that you use to power your phones or chargers or whatever, वो क्या कर रहे हैं? They are taking energy and giving that to a charge. So charge ko, they're stuffing it with more and more energy, or they're doing more work on it so it starts to move. So if that happens, if you're going to give energy to charge, that's called electromotive force. To be more precise or more clear, what we can also say is that, remember that charge carries electrical energy. Okay, But when you're giving energy to the charge, you're giving it electrical energy, but it's not necessary that it got it from an electrical energy. So maybe you are taking heat energy and you're converting it to electrical energy, or for example, in the case of sunlight, or maybe you are taking electromagnetic waves energy and converting it to electrical energy, just like solar cells do. Okay, so there are two things, solar panels and solar cells. Solar panels जो हैं वो heat को use करते हैं, solar cells जो हैं वो electromagnetic waves की energy को use करते हैं. We already talked about it in last week. Similarly, you can have tidal power, which has basically gravitational potential energy, and you transfer it to an electrical energy. So that's again, you're taking a form of energy which is not electrical. It could be heat, it could be potential, it could be kinetic, it could be any sort of thing. But you're converting it to electrical energy. And that is what the charge carries and goes away. That's why it's called electromotive force. So here energy goes from non-electrical to electrical. Okay. So when that happens, we call it electromotive force. Now, on the other hand, potential difference, which we'll call PD. PD is when you take energy from the charge. So charge had energy, it passed through a bulb. So the bulb took its energy and started to convert it to light. Or charge had energy, it passed through a speaker and that speaker took it and converted it to sound. Or a TV converted it to light and sound. Okay. Or a fan took it and converted it to kinetic energy. So you can take electrical energy from the charge, and that is the most remarkable thing about electricity, that no matter what work you want to do, what form of energy you need, just take it in electrical form and convert it. Okay, and electrical energy is able to go at very fast speeds, and it is with very little loss. So that's why it's really, really good. आप अगर heat energy transfer करना चाहें तो आप कर तो सकते हो. For example, मैं लाहौर में हूँ, मैं यहाँ पे तरबेला से heat energy मंगवाना चाहता हूँ. So the distance of, I don't know, 800, 600 kilometers. और वहां से चीज यहाँ आते आते ठंडी हो जाएगी, सीधी सी बात है भाई. Even if I insulate it a lot, still there will be a large loss of energy. But electrical energy तरबेला से शुरू होती है, लाहौर आते आते बहुत ज्यादा loss नहीं होता उसका. Sure, loss is there, and especially in a country like Pakistan where we cannot have, we do not invest enough in our infrastructure, purani tare and all that. But still the loss is much less compared to any other form of transfer that we have. So that's why it's so remarkable, electricity. So in potential difference, you take electrical energy that charge carries and you convert it to non-electrical one. And if you do that, then we call this potential difference. So the two differences in voltage, remember both of them, voltage is simply energy or work done per unit charge. But if you're giving that energy to the charge too, so that is electromotive force. If you're taking that energy from the charge, that's potential difference. So in EMF, it goes from non-electrical to electrical. Why? Because charge can only carry electrical energy. Charge will not carry heat energy as much. Similarly, potential difference is charge has electrical energy. I take it and I convert it to non-electrical one. It could be anyone, any form of heat, any form of energy. So that's why we call it potential difference. Okay. So that's the voltage. So now we have talked about two main things: voltage, which is about energy and its relationship to charge, and current, which is about charges and how much they're flowing per unit time. All right. So the third thing that we need before we build our model of current electricity is resistance. Sorry about that. Now, resistance is hard to define. Okay, so a usual idea that people get from the name is कि resistance का मतलब है कि उसको कोई चीज resist कर रही है, ठीक है? Electrical current wants to flow, and that thing is just opposing the flow, right? That's a little again weird way of defining it. So what I will do is I will start with the idea of conductance. Conductance is basically the ability or how easily charge can flow through something. Okay, so how easily something goes through something, that's called conductance. And the opposite of conductance is resistance. Okay, so if you understand conductance, just remember that conductance, if we call it G, again named after, I think Galvin naam tha scientist ka, jisne ye kiya tha. Okay, I'm not sure. It's been a long time. I remember this. So resistance would be reciprocal of this. So it will be 1 over G. So that is what resistance is. Another way, another name that we give to resistance and some other things is impedance. That how much does it impede the flow of current? So how much it allows the flow of current, that's conductance, and how much it impedes, how much it stops, how much it resists, that is resistance. Okay. Now, one way by which we define it, resistance, क्योंकि resistance को measure कैसे करोगे आप? So one way that we define it is that resistance is the ratio or the rate of change. Remember rate of changes? So voltage over current. So how much does the voltage change if the current changes? So one way of thinking about it is, okay, if I increase the current by 1 ampere, यानी कि जितना करंट फ्लो कर रहा है मैं उसके अंदर 1 एम्पेयर इंक्रीज कर देता हूं. सो अगर 2 एम्पेयर चल रहा था मैं 3 एम्पेयर कर देता हूं. हाउ मच मोर एनर्जी डू आई हैव टू सप्लाई टू चार्जेस टू मूव? तो अगर मैं करंट मूव करता हूं, करंट इंक्रीज करता हूं, हाउ मच मोर एनर्जी कैन आई ट्रांसफर पर यूनिट चार्ज? ठीक है, या उसको ट्रांसफर करने पे मुझे कितनी एनर्जी और देनी पड़ेगी? दैट इज व्हाट रेजिस्टेंस इज. ओके, so resistance is rate of change of voltage compared to current. But a better way of explaining this or defining it is where we get Ohm's law. Ohm's law simply says that V equals IR. And in fact, what it's actually trying to say is that voltage is directly proportional to current. Conductance and conduction are two different things. Yes, conductance is how much something is allowing current to move on, and conduction is whether it allows it to move or not. Conduction also can mean different things depending on what context you have. In the case of heat, conduction would mean heat transfer by particles colliding with each other. But conductance means only one thing, and that is that how easily can current flow through something. Okay. Yeah, so conductance is an ability of something to do that, and conductance is how much it does that. Okay. So coming back to Ohm's law, Ohm's law basically says that voltage is directly proportional to current. So what is it saying? It's saying that if you try to increase the number of charges that you move, you would have to spend or supply more energy for each charge that you have. So it's really important to understand this. The more charges you want to move, the more energy it will take to move all of them. Every charge will now require more. Jitne zyada charges honge, every one of them is going to need more energy now. So jitna zyada crowded karoge aap, utni zyada overall energy deni padegi. That's Ohm's law. But turns out Ohm's law is not a universal thing. It only applies to handful of substances, jinko hum keh dete hain ohmic conductors. So things that follow this are called ohmic conductors. So ohmic conductors obey this. So why do we need this? Because it's ideal. It's a very ideal proposition. क्यों? आप अगर इसका ग्राफ बनाते हो, डायरेक्टली प्रोपोर्शनल थिंग्स में क्या होता है? आप अगर यहाँ पे करंट लिखते हो, यहाँ पे वोल्टेज लिखते हो, क्या होता है? ऐसे डायरेक्ट स्ट्रेट लाइन बनती है. दैट इज डायरेक्ट प्रोपोर्शन. ओके, आइडियल केस, उसका ग्रेडियंट कम ज्यादा हो सकता है. अगर ग्रेडियंट ज्यादा है तो इसका मतलब है वोल्टेज ज्यादा देनी पड़ रही है, करंट कम फ्लो करता है. फॉर द स्मॉल अमाउंट ऑफ करंट चेंज आपको वोल्टेज ज्यादा फ्लो करनी पड़ी. फॉर इट कैन बी इफ इट इज गोइंग टू बी नेगेटिव. सिमिलरली if you change the direction of current, so if you have negative current, that simply means it's flowing in the opposite direction, then you will have to switch the direction of energy per unit charge. What does that mean? That means कि जिस direction में आप उसको flow करा रहे हो उसी तरह energy कम या ज्यादा होगी. अगर एक left to right जाने में energy spend हो रही थी, अब right to left जाने में energy spend होगी. The things that follow this, we call them ohmic conductors. Metals are very good ohmic conductors. They follow this. But if something deviates from this, that is not an ohmic conductor. Another important thing, और ये चीज एक general rule है जो आप याद रख लो. Whenever you have a graph, just divide y by x to figure out what the gradient is. Okay, and that obviously you know comes from the definition of what a gradient is. Okay, so over here y is voltage and x is I. So what does that mean? The gradient is resistance. So the gradient of such a graph is resistance, and you can see that resistance is constant. It's a straight line. Resistance does not change. And that is what ohmic conductors are. And that is why we have R in here. That resistance does not change. It's constant, regardless of how much current you're trying to move through or how much voltage you're giving to those charges. Okay, so that's Ohm's law. Now, for most components, this is not true. So if you take a diode or a transformer or batteries, they don't follow this. Not at all. Okay, but जो हमारे पास usually metals होते हैं वो इसको follow करते हैं. In fact, we take what we call IV curve, ठीक है? And IV curve क्या होती है कि हम इसका उल्टा बनाते हैं. हम यहाँ पर करंट रखेंगे, यहाँ पे वोल्टेज रखेंगे. अब इससे हमें इसका ग्रेडियंट क्या होगा? I over V. So what do you think that is? I over V क्या होता होगा? So if V over I is R, then if I flip this, I get 1 over R. And what is that? That's conductance, right? How easily does something allow current to flow? That's what this graph is, which is why it's more meaningful to draw IV graph compared to VI graph. क्योंकि IV graph में हमें current is on the y-axis और हमें conductance का पता लग रहा है और हमें पता चल रहा है कि कितनी current easily flow करेगा और कितना मुश्किल से flow करेगा. So the higher gradient you have, higher the conductance, better the conductor. The lower gradient you have, worse the conductor. अच्छा, so अगर हम इस IV curves को देखें, तो for ohmic conductors it just goes like this. So a straight line that passes like that. But what about other things? Things that do not follow ohmic conductor, which are not ohmic conductors, sorry. So what about those things? So let's see, there are a few ohmic conductors that you need, non-ohmic conductors that you need to talk, that you need to be familiar with. So I'm going to do it for 4 things, okay? And we're briefly going to see how that works. We are not going to talk about these in detail, क्योंकि हमें ज़रूरत नहीं है ये देखने की कि भाई ये कैसे चलता है, ठीक है? So for example, if I talk about this, let me choose a different color. Yeah, so let's suppose I talk about this. So this thing compared to, okay, so I have 2 green lines here. Let me call that, this one is line 1 and this is line 2. Okay, and these are IV curves. Okay, IV, yeah, so this is IV. Okay, so which green line do you have is for a better conductor? What does it mean? Line 1 you're saying कि उसका gradient ज़्यादा है, right? So how does that make it a better conductor? Gradient ज़्यादा होने का मतलब है the y-axis value increases for unit change in x-axis value. So आप इसमें थोड़ा सा voltage increase करें तो current काफी ज़्यादा increase होता है compared to the other one. So अगर current ज़्यादा increase हो रहा है, that means it's allowing more current, more charges, so it's a better conductor. The other one, line 2, that has a lower gradient, which means it's a not as good a conductor as the other one. क्योंकि for the same change in voltage, it will have lower change in current. सोचो ना अगर मैं voltage इस point से इस point पे increase करता हूँ, ठीक है? Now let's see how does that change x-axis and how does that change the y-axis for these. So for this one, the change is this much. For this one, the change is this much higher change, right? So there's a greater change in y for line 1 compared to line 2. So that's why line 1 is for better. So the conductance of this one will be greater than conductance for the other one. In other words, I can say that the resistance of line 1 is less than resistance of line 2 because resistance is opposite of conductance. So if you understand conductance, you can easily reverse it for resistance. Okay, what if we don't have this? What if we have something like a filament lamp? Usme kya hoga? So this is basically ohmic conductor. Okay, they always follow this. So now what if I have a, so I'm going to talk about 4 things. I'm going to talk about filament lamp. I'm going to talk about semiconductor diode. So I'm going to talk about diode. And तीसरी चीज कौन सी डिस्कस करनी चाहिए? I think तीसरी चीज हम करेंगे एक सेमीकंडक्टर्स को कर लेते हैं, डायोड्स के अलावा सेमीकंडक्टर्स को देखिए. In filaments, what you can do is you will get a curve like this for a certain amount of voltage. कि खास जगह तक वो इस तरह करेगा. But after that, its conductance will fall and it will go like this. So it is straight up till a certain point. It is an ohmic conductor up till a certain point. We can even draw a straight line like that. ठीक है? एक खास amount तक वो ऐसा करता है. But after that, its conductance starts to fall and it goes like this. Similarly, on the other side, it goes like this. That's what a filament lamp does. So शुरू में वो आपको बहुत ज्यादा allow करता है कि जितने मर्जी वोल्टेज भेज दो, जितनी मर्जी करंट भेज दो. But then what does it do? It starts to limit how much current you are able to move through it. ठीक है? और फिर आप जितना मर्जी करंट लेके आने की कोशिश करते रहो, करंट को वो ज्यादा नहीं होने देता और आपकी वोल्टेज ज्यादा करता है. वोल्टेज ज्यादा होने से क्या होता है? वोल्टेज मींस एनर्जी पर चार्ज. सो इट टेक्स मोर एंड मोर एनर्जी. और अगर वो करंट नहीं मूव करने दे रहा तो वो एनर्जी कहाँ जा रही है? इट स्टार्ट्स टू गेट हॉट. And when it's hot, it glows. So it's getting more and more energy and it's glowing and it's giving that as heat and light. But it's a very bad way of making light because it wastes so much energy as heat. Okay? So it limits current. That's what you have to remember. Filament limits current. वो current को एक amount से ऊपर नहीं जाने देता. Diode is the opposite. Diode limits voltage. So यहाँ पे voltage है, यहाँ पे ये है. Diode voltage को limit करता है. एक limit, एक खास जगह तक वो straight line होती है और उसके बाद वो voltage को limit कर देता है. वो एक amount से ज़्यादा voltage को नहीं increase करने देता. ठीक है? That's what a diode does. And in the other side, diode current को limit करता है. And that's very interesting. On one side, in one direction, let's suppose the positive direction, diode does not allow voltage to exceed a certain value. उससे क्या होता है कि आप करंट बढ़ाते जाओ, करंट गुजरता जाएगा, लेकिन एक खास अमाउंट से ज्यादा वोल्टेज नहीं करने देगा वो. इन प्रैक्टिकल टर्म्स वो बेसिकली वो तबाह हो जाता है. तब तक उससे ज्यादा वोल्टेज वो बर्दाश्त नहीं कर सकता, तो वो खत्म हो जाता है, जल जाता है. बट that's what diode does. It cannot allow charges of, it allows so much charges but does not allow them to carry more than a certain amount of energy. And on the other side, वो कहते हैं एनर्जी जितनी मर्जी ले आओ, मैं तुम्हें गुजरने नहीं दूंगा. It stops the flow in one direction. So diode का फायदा ये है कि it allows the flow in one direction and does not allow it in the opposite direction. And diodes are remarkable for doing that. ठीक है? Acha. So that was diode, and then we have this filament lamp. So filament and diode are opposites of each other. Oh yes, thermistor. अच्छा, अब thermistor जो होता है ना, वो diode की ही एक form है. ठीक है? So thermistor does the same thing. बस thermistor जो है उसको आपके syllabus में उन्होंने सिर्फ एक direction में देखा हुआ. So it follows it to a certain extent and then it stops. So this is thermistor. ठीक है? So diode का दोनों sides का आपको बताना चाहिए और thermistor का सिर्फ positive side उसने मांगी. And that's just like diode. So diode and thermistor have the same graph. Filament जो है वो opposite है. In fact, filament का भी उन्होंने सिर्फ positive side का मांगा हुआ. And ohmic conductors we have talked about. So that's conduction. That's voltage, current, and we have completed our model of how electricity flows. One last thing that's left is power. How does power get delivered? Power is energy over time. So all you're doing over here is you're taking energy, giving it to a charge, and making that charge move per unit time. So what are you doing? You're taking energy, giving it to charge, making that charge go around and around, and that is V times I. So that's what power is. Power is velocity, velocity कह रहा हूँ, voltage times current. So हमारे पास अब क्या हो गया, हमारे पास एक voltage है, एक current है. Voltage is energy that you give to charge. Current is how many charges allowing for time. If you divide them, you get resistance. If you multiply them, you get power. And these are the 4 important facts that we will build our model of current electricity on. Okay.